Lesson 6.4, the triangle midsegment theorem. Try drawing a triangle in your notes. So find just a blank spot in your notes. You'll need a ruler. So there's my triangle. Pause when you need to do your drawings. Find the midpoints at two sides of your triangle using a ruler. So you'll probably have to pause this to do that. There's my midpoints. Connect those with a segment. So use your ruler to draw a nice straight line. Measure that segment. For me and my iPad, that is 8.5 centimeters. And this other one is 17 centimeters. What do we notice? Well, I notice 17 is 2 times 8.5. So I notice the third side is 2 times the middle. What else do we notice about those two segments? That's right, they appear to be parallel. The midsegment of a triangle is a segment that connects the midpoints at two sides of a triangle. So those are congruent, those are congruent. And our midsegment theorem says what we just found, that the midsegment of a triangle is parallel to the third side and is half as long as that side. So the parallel and the midsegment's half as long. So if this third side is length is 2x, the midsegment's length is just x, or half of that. So in our triangle, let's show that MN is parallel to RS, and that its length is 1/2 RS. Alright, so for the parallel business, I think we need to use slopes. So the slope formula, but we need some points. So R appears to be 2, 5. M appears to be 3, 2. N is 1, 0. And S is -2, 1. Alright, so let's start with the slope of MN. Alright, so y2 is 2. y1 is 0. x2 is 3. x1 is 1. So I'll have 2 over 2, which is 1. The slope of RS. y2 is 5, y1 is 1. x2 is 2, x1 is -2, so that's 4 over 4. Remember, minus a negative is a plus, which gives us 1. So the same slope means parallel. Look at that, we've done the parallel part. Now let's do the distance part. For that, we'll use the distance formula. Remember, it's x2 minus x1 squared plus y2 minus y1 squared. So let's start with MN. x2 is 3, x1 is 1. y2 is 2, y1 is 0. Alright, 3 minus 1 is 2, squared is 4. 2 minus 0 is 2, squared is 4. So that gives me the square root of 8. We can probably simplify that, though. 8 is 4 times 2. The square root of 4 is 2. Or you can just put it in your calculator. RS. X2 is 2. X1 is negative 2. Y2 is 5. Y1 is 1. 2 minus negative 2 is 4. Squared is 16. 5 minus 1 is 4. Squared is 16. 16 and 16 makes 32. Oh, but wait, that's 16 times 2. The square root of 16 is 4. Square root of 2. So, Mn is 1/2 RS would be 2 square root of 2 is 1/2 4 square root of 2. Wait, what's 1/2 of 4? Is 2. Look, both sides are the same. So, yay! Check mark. We've done both parts. It's parallel and half the length. Why don't you pause this and try number 2. So let's try an example. Here's a roofing truss. And this roofing truss, let's name the midsegments. Assuming that the points are midpoints, that's one midsegment, UV. Remember, we're connecting midpoints here. So there'd be another one, VW. And let's just go with those two, the ones that are drawn on our picture. There is a third one. We'll get to that in a minute. See, draw the third midsegment. It has to combine the midpoint, so it's going to combine U and W. So that was VW. This is UW. All right, let UW be 81 inches. Find VS. Okay, S is up here. Well, we know that the midsegment equals 1/2 the third side. So our midsegment is UW, and our third side is TS. So UW is 81. If I multiply by 2, I get 162 for TS. But since V is the midpoint, VS is going to be half of TS. TS was 162, so VS is 81. Notice, the midsegment's 81, and then each half of the other side is the same length, 81. I want you to pause this and try number 8 and 10. Let's try a proof. Given CF equals FB and CD equals DA, prove DF is parallel to AB. Okay. What is our first step? That's right. Put the given. CF equals FB and CD equals DA. So usually for step 2, I say, hey, what are vocabulary words? But it's just equals. Equals isn't necessarily useful. So let's look at the picture. Well, from the picture, what do you know about points F and D? Since they divide a big segment into two equal parts, that means they are, that's right, midpoints. And that is the definition of midpoint, because a midpoint is the point that divides a segment into two congruent parts, two equal lengths. All right. Now, we use midpoint to get there, so we're not going to use the definition of a midpoint. But we can look and say, oh, hey, what do we know about DF? Since it connects the midpoints, DF is, what's that word? That's right. It's a midsegment. Definition of a midsegment. Now, if it's a midsegment, what do you know about midsegments that we want to prove? Oh, that's right. We know that the midsegments are parallel to the third side. Therefore, DF is parallel to AB. Reason, it's not the definition of midsegment. That's just saying it connects the midpoints. What it is, it's the midsegment theorem. Or I guess the triangle midsegment theorem. Why don't you pause this and try number 6.